Not this time. No, not this time. It's totally made up. Pure fiction.
We're not talking about this or this. We're talking about this.
My name is Pat Schuff, and this is Making the Space. Today we're going to be analyzing what it takes to build a fabrication lab using 3D printers or a home lab if you want to build one by yourself rather than creating a makerspace. We're going to analyze a couple machines. We're going to analyze the cost and analyze all the tools needed and the overall economics of building a fabrication lab. So if we break down the cost of what it would take to host a 3D printer, specifically the Prusa 3D i3 MK3S, buying it by a kit would be $750. A toolkit would be needed along with it. If I'm hosting this in a fabrication lab, I'm going to need a work table, a bookshelf to put prints when they're done so that it could be a community type environment, and then a drawer to store filament so everybody's not having to carry filament with them every time they bring stuff in and take stuff out. So to host one machine, we're looking at a capital expenditure of about $1,100. There is some minimal expenditures that happen for replacement parts. If you looked at the maintenance video that I released last week, the Pendaprobe, the hot end, the filament gear, and the thermistor are probably the big ones. They're not that expensive, but we're looking at maybe $430 annual expense for maintenance and printers and using the print to do test prints to calibration and stuff like that. So we're looking at roughly $1,500 to host a 3D printing facility with one printer. If we use TXRX as a foundation for how to build a fabrication lab, they actually run 6 printers, and the 6 printers require 3 work tables and 2 bookshelves, along with 5 drawers for storage. And then the number of probes and everything, assuming you're going to replace one per year, the probes, the hot end, the filament gear, the nozzle, the thermistor, those all total up to about $7,600, with $6,900 being the capital expenditure cost, with annual expenses being about $646. One of the primary ways that most labs recoup their cost is to teach classes. With 3D printing, it's got a pretty high demand. You can teach a class one day a month. Usually you can put about 12 students into a class. You're looking at $70 per class. So that will not only pay to recoup the resources, it will encourage more people to come in and use the equipment and provide finances to keep staff employed. So if we do a quick cost recovery analysis, we're looking at a dozen students every month at $70 a cost, which will generate $840 worth of income for the lab, and roughly $10,000 per year. Our capital expenditure to build the labs was $6,900, with operational expense being about $4,000. And with this, we actually include the $1 per square foot for the 100 square feet that would be required to host the lab. So in general, we're looking at 13 months to recover our capital expenditure and about $6,000 headroom for salary. Now, if you break down staff time, we're looking at 8 hours of teaching per month, 4 hours of prep, 4 hours to teach, and then 1 hour per machine per week, or about 24 hours per month. We're looking at 32 hours worth of work, which is about a 20% of a full-time employee. Break this down. On the left-hand side, we've got the cost of doing one machine. We've got the cost of doing 6 machines in a full lab facility. The overall lab cost is about $6,900 CapEx with $650 annual OpEx. If we assume a 300 square foot, a 30 by 10 room to host 6 printers, which is 3 8-foot tables, basically that gives us $300 a month in rent, or $3,600 a year in rent for that space. We can generate revenue of $10,000 a year by teaching classes, and it takes about 1/5 of a full-time employee to keep this facility up and operational. So if we take a perspective of the lab, there are 6 machines on 2 very large 10-foot tables. They are steel-based tables with cement top, so they're very solid. Those were built in the lab. Equivalently, you could buy tables at about $200 each. Notice the 2 shelves in the corner that are basically holding prints that already happened, and if you turn to the right and look at the other printers on the right-hand side, you'll notice a toolbox containing all the hand tools and all of the necessary tools needed to keep things functional and operational. The other component that's needed for the lab is filament storage, and in this case, steel case drawers are used as well as wooden drawers on 2 sides of the lab. Some of the drawers are well organized, some are a complete mess, but it's up to the users of the lab to keep things straight and neat, but the staff typically does not organize drawers. Now on the flip side, if you're looking at getting a 3D printer for your house and just playing with this technology on your own and not having a membership to a lab, you're looking roughly at $100 for a table to set this on. That's optional. You don't necessarily need that $100, but you do need $750 for a printer. You're going to have to assemble it from a kit. You'll need some tool kits, and then you'll need all the consumables. So your capital expenditure will be anywhere from $780 to $880, with your annual operation expense being about $400 for mostly a new hot end if you're going to use it a lot, and for filament. If you're going to go through once a quarter a 1 kilogram spool, I've listed the 3 types here. They're all about the same, but you're going to need a 4x3 area to put the printer on, to put the spools on, to store things in. So, give up 12 square feet of your house to do this at roughly $1,300. So to summarize, if I'm going to build a lab with 6 3D printers, I'm looking at $6,900 capital expense, about $3,600 to rent the space at $1 per square foot, $650 for operational expense on an annual basis, and I'm looking at 1/5 of a full-time employee to make this happen, and that is subsidized by teaching classes and having people come in and learn how to use the equipment on a monthly basis. And I'm looking at roughly a year to recover my initial capital expenditure, and then I can cover the salary after that. So if I'm writing a grant, I'd write a grant for about $7,000 and then have it self-sustaining for perpetual. If I'm looking at building a home lab as opposed to building a laboratory, I'm looking at $900 capital expenditure, roughly $1,000 depending on the printer that you get, and then $400 to $500 per year based on how heavily you use it. Space, noise, smell, all of those factor into where you'd put it, how you put it, but you can't put it in the garage because the temperature and humidity negatively affects it. So think about joining a lab or buying a machine. It's your choice. And with that, hopefully this helps you decide, is it worth building a fabrication lab if I'm hosting services for other people, if I'm creating a makerspace? Do I even want a 3D printer? It seems like it's economical, it's a good draw. Or if I want to build a home lab myself, here's what you budget. Here's what you use to go out and acquire something for yourself. And previous videos, we talked about maintenance, we talked about some of the tuning tips, we talked about how to basically get started on getting a lab up and running. So with that, we will end our fabrication lab, and the next one we'll do is a welding lab. Thanks for the time. If you like the videos, subscribe. If you don't like the videos, leave a comment. If you're looking at building a lab using other equipment, I'd like to know, do these numbers make sense to you? Do they not make sense to you? If you're a member of another lab, tell me how they do it different. I'm primarily looking at the Houston lab, trying to figure out how to expand this to rural areas. And that, thanks for your time.
Now back to your regularly scheduled program.
And while some may see them as the crazy ones, we see genius. Because the people who are crazy enough to think they can change the world are the ones who do.